In this example, we'll be solving real-world problems using bar models and algebraic reasoning. So let's start with the problem. We have Lisa wrote a riddle. It says that a positive number is 1/3 of another positive number. If their difference is 48, find the two positive numbers. I'm going to start with algebraic reasoning. So here's what I know. I know we have two numbers, and I'm just going to list them as my first and my second numbers. I know that the positive number is 1/3 of another positive number, but I don't know what this positive number is. So this positive number, I'm just going to give a variable. I'll give a variable p for positive. And I know that the other number, I know that a positive number is 1/3 of that. So 1/3 of that positive number. Now here's what I know. I know that their difference is 48. So I know that their difference is 48, which means we're going to be using subtraction. So we're going to take these two numbers, we're going to subtract them, and we're going to get an answer of 48. So it's something minus something equals 48. Now we want to determine how to set this up. So we know that both numbers are positive because it says a positive number is 1/3 of another positive number. So if we're looking at the numbers, I'm going to put the bigger number first, and my bigger number here would be p. P is bigger than 1/3 of itself, so I would have p minus 1/3 p equals 48. Now we have an equation that we could solve. I'm going to split it up. And if I have, I'll make this a 1p. 1p minus 1/3 p is 2/3 p is equal to 48. To solve for p, I'm going to multiply both sides by the reciprocal, which is 3/2. I'm just going to make this a 48 over 1 there. So on this side here, my coefficient cancels out, so I'm left with p equals, and now we have 48 over 1 times 3 over 2, and I'm going to reduce here beforehand. I'm going to make that a 1, and this 48 is going to become a 24. So now on top, I'm left with 24 times 3. 3 times 20 is 60. 3 times 4 is 12, so that leaves me with p equals 72. Now in our problem, we want to find the two positive numbers. So to find the two positive numbers, I'm going to plug in 72 for both of these. And I know the first one is going to be 72 because p equals 72. And then the second one is 1/3 of 72. So if I had 72 divided by 3, well, 72 divided by 3 would give us 24. We could also check our answer here to see if it works. It says that one number minus the other number gives us 48. So what I could do quickly is 72 minus 24. And when we subtract here, 7 becomes 6. That becomes a 12. 12 minus 4 is 8. 6 minus 2 is 48. So when we subtracted 72 minus 24, we got a difference of 48, just like the problem told us. Therefore, we know that our solution of p equals 72 is correct. And we know that both numbers were 72 and 24. To show this with a bar model, I'm going to go with the same setup of my first and second number. And my first number, I'm just going to break it into thirds because I know that the second number is 1/3 of that number. So here's thirds here. And my second number is just going to be 1 block. And here's what I know. Using the bar models, I know that their difference is 48. So their difference is this section right here. These two blocks have to equal 48. So if these two blocks equal 48, that means one block is 24. And then in each spot here would be 24. I'm going to fill each block with 24. Those are 24s, although they may come up looking like 9s. So if each block is 24, I could figure it out this way now. I know that my second number is 24, and then my first number here is 24, 24, and 24. So 20, 40, 60, 64, 68, 72. My second number would be 72, or my first number is 72, and my second number is 24. And again, we could check this by subtracting them. We should get 48. So when we do 72 minus 24, that does give us our difference of 48.